Hi everyone. So welcome to this session. I'm just going to solve one question from electronic devices. This question was asked from, you can say, MOSFET topic, okay, in GATE 2024. So I'm just going to tell you that everything is given in the question. Only the thing is that you need to recall is the formula and the important fact related to region of operation in case of when you're solving MOSFET problem, right? So let's see the question. And this was one of the easiest question, but many of us were did not solve it. Many of us were not able to solve at that point of time. Okay, so the question was an NMOS transistor. So here they have given NMOS transistor, okay, operating in a linear region. So they have already specified that you are operating in the linear region. Please remember this point. The very first point that you have to keep in mind is the NMOS transistor operating in the linear region. What is the condition for linear region? Everybody must know that. That is nothing but VDS should be less than VGS minus VT. This is the very first condition, okay, that you have to keep in mind, right? When your NMOS transistor is in linear region, means VDS must be less than VGS minus VT, okay. They have given the current here, IDS is 5 microampere and at VDS equal to 0.1. So here the VDS is quite small, right? 0.1 volt. Keeping VGS constant, you have to now increase VDS. So now new VDS is given to be what? That is 1.5 here, right? So this is new VDS. But now you don't know in this question what? You don't know in this question basically what is the value of VGS minus VT. Since they did not mention about VGS, they did not mention about VT here. That is overdrive voltage, okay? So what is our first job? First job is to find out VGS minus VT, and then we have to compare that VGS minus VT with given VDS that has been increased to 1.5. If that is greater than, if this VDS, new VDS that is given in the question, you can say, if this VDS is greater than, let's say, this VDS will be greater than VGS minus VT, okay, or equal to, you can say, then our transistor will be in saturation region. Okay, please keep this in mind. These are important facts. Okay, so what is our job? The very first job is to find out VGS minus VT from this question, right? So how to find VGS minus VT? Since NMOS transistor given NMOS transistor is in linear region, so you should know the equation for the current in linear region. Okay, so can we move ahead and have a look? Okay, so what is the equation in linear region, guys? That is id equal to, you don't have to write equation also, but it's okay if you want to write mu1 cux w by l vgs minus vt times vds minus vds square by 2. This is the equation that everybody knows, okay. But now where we find challenge, when we plug value, okay, to the this equation, okay, since id is given, everything is given here, okay, id is given as 5 micro and mu1 cx w by l is given as 50 micro. Okay, so what you can do here is, this is given as 5, okay, micro, and this also has got micro, so it will get cancelled. Please don't put micro now, right? Micro gets cancelled. You don't know this vgs minus vt, so you have to find out, okay. You know this 0.1, and please keep 0.1 as it is, right? 0.1 whole square as it is. Please don't disturb, okay. I'm just going to show you how simple this question is and how simple manipulation is, right? We most of the time face this kind of a equation and get lost into mathematics, right? But in the gate examination they never give you a kind of question where you have to feel difficulty while manipulating. You see, id is 5 microampere, mu1 cux w by l is given as 50 micro, okay, something ampere per volt square something is given. Can we check that? What was the unit? I forgot. Yeah, microampere per volt. So now what you can do here is, you can take this 50 this side, so that is 5 by 50. 5 by 50 is what? What is 5 by 50, guys? 5 by 50 is nothing but 1 by 10, right? Which is 0.1 only. You see, simple manipulation, 0.1. So, if you write here 0.1, so it is also having, VGS minus VT. Okay, 0.1 minus 0.1 whole square by 2. Don't disturb, please. Don't take square of 0.1 and all, like 0.01 kind of, okay, because 0.1 0.1 0.1 is going to get cancelled, right, from both sides. So what you can do here is it will become 1 is equal to, this is VGS minus VT minus 0.1 by 2. Okay, I think this is a very simple equation anybody can solve. Now the next step is going to be what? You have to take this guy this side, okay, and then you can move to next, right? So 1 equal to VGS minus Vt minus 0.1 by 2. You take this guy this side, so you can say, right, VGS minus Vt equal to 1 plus 0.1 by 2, which is nothing but 2.1 by 2. Okay, now you will get here what? 1.05 something. You can just divide this, you will get VGS minus Vt as 1.05. See, I haven't got lost into mathematics, guys. Okay, very simple manipulation. So if you are practicing enough and if you are determined to crack gate this year, you will never get lost into mathematics. Okay, question was very simple for 2 mark. Only the thing is we always get stuck, we always get afraid about solving quadratic equations, right? We always get afraid about solving anything we come across, right? हम चाहते हैं कि बस सब कुछ लाइफ में ऐसे ही हो जाए, ऐसा नहीं होता है. You have to be attentive while solving the question. 1.05 आ गया ना. अब देखो जो गिवन VDS हमारा दिया था, what is given VDS, that was increased. So your VDS, which was earlier, sorry, VDS was 1, earlier it was 0.1, now it has been 1.5 volt, right? So you compare this and this. Earlier it was, VDS was less than this VGS minus VT, right? So that was in linear. But now, since, VDS is greater than VGS minus VT, like 1.5 is greater than 1.05, it means what is the meaning of that? Your transistor is now switches to saturation region, right? And you know how to compute GM. In the question what they are asking is, they are asking you to compute the transconductance at the new operating point. Okay, see, your VGS is constant, they have already given your VGS is constant. Threshold voltage will also be constant only, right? It is not going to change. Only what is changing? Once you are changing VDS, your transistor has been switched to saturation, right? So you should now know that. I'm just going to write here itself. The GM is equal to what? That is mu1 CUX W by L VGS minus VT. I think everybody knows how to find this formula, right? Or you can also directly remember it, or what you can do here is, if you want derivation, I'm telling you, you should know the equation of drain current, okay, in saturation region, and you can say then differentiate it, okay, differentiate that with respect to VGS, and you will get that GM, right? That is transconductance. I will show you after getting the answer. Now this is given, what is this? This is 50, and that is 10 raised to power minus 6, okay, and this is also given, that is 1.05. So if you multiply this, already I have done multiplication, so you will get here, I'm just going to bring that calculator value, right? So you are going to get here this much, this value, okay, 52.5, right? This 52.5 is the correct answer here, 52.5, and you have to round it off to 2 decimal places, so you can say 52.50. That's it. How simple this question is, and this question was asked for 2 mark. Okay, now let me tell you how we have got this GM, right? So since we know that our transistor is in saturation, so ID sat क्या होता है? That is 1 by 2 mu1 CUX W by L, okay, VGS minus VT, okay, का whole square, VGS minus VT का whole square, okay. Now what we can do here is, you can just differentiate this, right? VGS with respect to VGS, so this 2 will come down, right? So it becomes mu1 CUX W by L, okay, VGS minus VT. That's it. And this guy is nothing but your GM. of the transistor. Okay, so I hope you guys might have understood how we have to solve the question. So what are the learning? In the question only each and every information will be given. You have to just utilize it in a proper sequence, okay? And don't get worried at all. Just go through the question confidently, use the information, use the equation that you know, 1 inch long equation, right? For the current in linear region. Okay, so in MOSFET, you know, MOSFET problems are quite easy. If you know the equation of drain current in different regions, and when you will be in linear region, like when MOSFET will be in linear region or saturation region, how do we compute transconductance? What are the different forms of transconductance formula in terms of, you know, ID, VDS, all those? Okay, you should know that. Life is going to be very simple. I hope this solution strikes in your mind. Hopefully in GATE 2025, if you're going to get the same kind of question, you will be able to crack it. Thank you.